Welcome back, guys. In this episode we're going to discuss importing in some GIS Topo into a survey file or a project model that already has survey topo in it, and I'm going to go over some techniques to locate that, situate it with a horizontal benchmark, and look at the differences in vertical benchmarks as well. But let's get into it and learn how to bring those in and align things up. Let's learn. Hey guys, in this quick episode I'm going to show you how to stitch together some topo from two different files into one, trying to find some common point or benchmark to tie them together. In this scenario, one of the projects is not on state plane and the aerial has been adjusted to match this project. But since it's not on state plane and this topo that we've gathered here from Cherokee County GIS is on state plane, we can't just simply drag and drop them or copy and paste them in together. So I've gone into this aerial and found a common point like this manhole. Circles are good because then you can use the center of a circle and just match the circle in general. So we have that circle in both, drawn the same size circle in both of these things here. We don't ever want our, if we're bringing in two pieces of topo, we don't want them to overlap. We always want to leave a gap because they're never going to line up exactly. So I've drawn this boundary around the outside of the existing topo. I'm going to show you here. I've drawn a boundary around the edge of that, and then I've offset it by 10 feet. So if we copy that offset from the center of that over to this drawing and we paste it at the center of that, now that's where our survey data is. And I'm just going to chop off some of this other topo here. Didn't work great. Let's try this T for cutting edge. That worked a little better. TR, T for trim. And then maybe we'll chop it up this way. Side of the property. So let me turn off, I probably should have done this before, turn this off so we can see a little bit better. Okay, so now we have the area of our topo and we can stitch this back in, make sure we're in world again. I'm going to delete that. I'm also going to change the name of this topo so that we can tell the difference and I'm going to call this VG Major 10 GIS, and then the 2s, I'm going to change the name. I'm doing this on another screen. 2 GIS for the 2-foot contours, and now when I select these, you can see that they have that GIS in the name. And so we'll grab that, copy from the base point of the center of that circle. Then we'll go back into our drawing, make sure that we're in world again, and then paste from the center of that circle. And now you can see that we're not getting too close. 46, 44. So these are off by about 2 feet, which is not uncommon. I mean, that happens regularly. And I'm going to change this line type back to by layer so that they're dashed, and then we don't need this anymore. So now we have some topo in here. This is on the regular layer, and then this was on the GIS layer, so that we can tell the difference between the two. And we have a gap where we're not saying this one goes all the way to there, because we know that's incorrect. There's some gap in here where this one's made off of one vertical datum, that's made off of a different vertical datum, and they're just a little bit different. But we can make some estimates based on this topo being in the roadway. So if this goes this way, if this topo is 56, and this one's almost in the same place. Let's turn on the road so we can see this. And actually that's not in the roadway. It would have been nicer if we were matching up in the roadway. If that one's 56 and this one is 58, we can tell that the GIS topo is about 2 feet different. Let's see how it looks here. Oh yeah, this is a good example. So this one's 44, and assuming that would go like that, this one is 46, that one's 48, this one is 6.1 feet out of 28.3, 6.1 divided by 28.3, which is 21%, 0.2, and 0.2 of a 2-foot contour, because this is a 2-foot contour from here to here. That's 0.4 feet. So this contour that I've just drawn is 20% of the way from the 46 to the 48. So that is 46.4. So we can infer that there's an adjustment of GIS topo is 46.4, so that's 2.4 feet higher in elevation than the survey topo. And now, for the purposes that we need to estimate a manhole over here based on this topography. But now we have something to roughly relate it back to what the elevation of our site is, and we're going to use this 2.4. Again, that's 46. That's 46.4. 47 is going to be there, and then this is 48. So going from 44 to 46.4 is 2.4 foot elevation difference.